To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Right, children. Now we are going to start the second chapter of this lesson. So in the first chapter, we learn about renewable and non-renewable energy sources and examples as well. So under renewable energy sources, we learn about solar energy or solar power. So even in this chapter, we are going to learn about some other renewable energy sources, right? So now we are going to learn about wind power. Now in the earlier chapter, I explained you all about the formation of wind. The formation of wind takes place because of solar heat or solar energy, right? So solar power heats different places on the earth unevenly. So I told you all, when you consider the earth, different parts get heated up unevenly, right? So let's consider if because of the presence of sun's heat, this area gets heated up, then what happens, children? The air layer next to that area also gets heated up and heated air rises up. Right? And then a low pressure area is created because of rising up of this heated air. Then what happens, children? A low pressure area is created. Then in order to fill these gaps in this low pressure area, air flows, and this is the flowing air is known as wind. Okay? So solar power heats different places on the earth unevenly. When the air is more heated, it rises up, generating a low pressure area in the atmosphere. Right? The cool air from other places flow into the gap, right? Into this gap, and the circulation of cool air is called the wind. Right, children? So here, how do we use wind power in order to do our activities? Now, wind is a source of energy. Now, how do we use the energy contained in wind to do our activities, children? Nowadays, most of the time, we use the wind energy to generate electricity in wind power plants. Right, children? And also, we still use wind power to dry clothes and other substances like grains. Okay? So here, ancient man used wind for many purposes. What are these examples? For winnowing paddy. What is the meaning of winnowing paddy, children? So when we consider paddy, so among this good paddy, sometimes empty paddy is also there. Only the outer cover called the chaff is present. Right? So you need to separate this good paddy from this empty paddy. So when you consider the weight of this empty paddy, it is less. Right? Therefore, what happens? We can get the help of the wind to separate this good paddy, like the high quality paddy, from this empty paddy, right? From the chaff. So then what happens, children? Even last year we learned about this winnowing paddy. So then in order to separate this good paddy from chaff, what we have to do is we should allow this paddy to fall from a certain height against the flow of wind. Right? So then what happens? Because of the flowing of wind, this light-weighted chaff is taken away with wind. But when we consider this heavier good part of the paddy, it just falls down. Thereby we can simply separate good paddy and the chaff. Okay? So for winnowing paddy means this separating chaff from the good paddy is known as winnowing paddy. Right? So ancient people, they used, for winnowing paddy, they always used help because they did not have machines. But nowadays we use fans and other machines for this purpose too. Right? Next one. For grinding grains using windmills. So you must have seen the pictures of windmills, right? Windmills had huge blades like this, right? So the windmill, inside this part, the windmill was there, right? Here what happens? The windmill, this huge blade-like structure, this propeller-like structure rotates in the presence of wind, and the axis of this propeller is connected to the machine where the grains are grinded. Right, children? So when the wind blows, what happens? This propeller rotates and then we can grind grains. So ancient people, nowadays we use electric machines for this purpose, but those days, ancient time, people got the help of wind. Okay, so for grinding grain using windmills, right? For transportation of sailboats, for sailboat transportation, the sail is there. When you put the sail, what happens? When the wind blows to one direction, what happens? Let's say if this is the sailboat. So then what happens? This sail, because of the blowing of wind, so this sail moves to one direction, moving the entire boat towards that direction. Right? So for transportation of sailboats also, ancient man got the support of the wind. Okay, children? Right. So here we have to do this activity to see how wind can generate electricity. Generate electricity using wind power. Okay? So what do we need to do this activity? We need a car cassette motor of 12 volts. Okay? We will write 12 volt car cassette motor. And then we need an LED bulb. We need a biscuit tin. Biscuit tin. We need the biscuit tin to fix some mega bottles, right? And then we need 3 mega bottles. 3 mega bottles. And then we need 3 bottle lids. Bottle lids. And then we need bolt nails. And a small pulley, right? And a thread, okay? And we need a thread. Right, children? We need a car cassette motor, LED bulb, a biscuit tin, 3 mega bottles, bottle lids, bolt nails, a small pulley and a thread. Okay? Let's see how to do this activity. So you have to cut the 3 mega bottles in a certain way that they look like wind blades. Okay? So we will label this diagram, children. When we label, it's easier to understand. So these are the mega bottles. Right? This is the biscuit tin and these are the bottle lids. Here you all can see you have to fix the bottle lids to the tin and then bottles to the lid. Bottles to the lids. Okay? And then we label them. This is the LED bulb, small motor. This is the thread. Right. Bottles, tin, bottle lids, this is the thread, motor and LED bulb. Right, children? So here, fix 3 wind blades made by cutting and removing a part of the bottle to those 3 bottle lids, okay? And then, don't forget to fix the bottle lids towards the corner of the biscuit tin lid. Towards the side of the tin, you have to fix these 3 lids because to the other side, we have to fix the thread, okay? Right. Fix the small pulley to the axis of the motor, right? This is where the pulley is present. Connect the car cassette motor of 12 volts with the twine thread in a manner as to be able to rotate this. Right? Rotate it. Okay? Connect an LED to the motor and rotate the turbine with the help of a fan. So what you have to do is, after making this setup, you have to fix this thread fix this band-like thread across this tin and then across the axis of the motor. Right, which means when this part rotates, this thread also rotates and thereby the motor axis also rotates. The two terminals of the motors are connected to the LED bulb. So when the motor rotates, the LED bulb should light up. Right, children? So we are going to rotate this big structure, fan-like structure using wind. Okay? So connect LED to the motor and rotate the turbine with the help of a fan. Record your observations. So increase the speed of the wind flow and observe the lighting of the LED. So when the speed is increased, what happens? The speed of the rotation of the motor axis also increases and thereby more electric current is generated, and thereby what happens? This LED bulb's brightness increases. Okay, so we will do this activity in the lab. Right, children. Now we are going to see how electricity is generated using wind power. Okay, so here I already explained you all how to make this setup. Okay, look at this one. Here you all can see this is a small tin can. Okay, I have made two holes from either side of this tin can and I have sent this spoke wire across the tin can. And to this tin can you all can see I have connected these three plastic bottles from their lids. Okay, children. And then I have passed this thread across this, around this tin can, and from the other side, it is passed around the axis of this motor. This is a car cassette motor. Okay, children. So you all can see to the terminals of this motor, an LED bulb is connected. LED bulb is not lighting up now. So how do we light up the LED bulb? So in order to light up the LED bulb, the axis of the motor should rotate. When the axis of the motor, now this axis rotates, what happens, children? This motor can generate electricity and thereby the LED bulb should light up. Now we are going to rotate the axis of this motor by rotating this tin and this entire structure with tin and the bottles. Right? So how am I going to rotate this big structure, children? Right? So I'm going to rotate this big structure with the power of wind. Here inside the lab, we don't have wind. Therefore, I'm going to use a vacuum cleaner to send air. When we rotate this structure, so as this thread passes around this tin can, that also rotates, making the axis of the this motor also rotates. Okay, so when the axis rotates, this bulb should light up. Okay, so observe carefully. Right, children. So you observed carefully because of this air current what happened? The structure with the tin can and the three bottles rotate, this big fan-like structure. When this one rotates, as this thread passes around this tin can and also around this axis of the small motor also rotates, and then you saw very clearly the LED bulb lights up. Okay, which means using the air current, using wind, we can generate electricity. The same type of process takes place in wind power plants, children. So if you consider in wind power plants, you all can see from outside huge blades. You can consider this structure as the huge blade. Okay, there in the wind power plant, to this axis a dynamo is connected. Right, children? So when this structure rotates, what happens, children? As this main axis is connected with the dynamo axis also rotates and thereby electricity is generated. Right, children. So you observed what happened. So we made the setup like this. So then what happened? We directed wind towards this structure with the bottles. So then what happens? The structure rotates, the structure with the bottle rotates, and then the LED bulb lights up. Right? So LED bulb lights up only when electric current passes through it. So here electric current is produced because because of the rotation of this big structure and thereby the motor axis. Right? So it's very clear after doing this activity, using wind, electricity can be generated. Okay? Right. Observation. When the structure with mega bottles. Structure with mega bottles is rotated due to wind. The LED bulb lights up. Lights up. Right? The observation is when the structure with mega bottles is rotated due to wind, the LED bulb lights up. So what is the conclusion? The energy contained in wind can be used to generate electricity. Right, children? The energy contained in wind can be used to generate electricity. Right, children? Okay. So here the same thing. It can be decided that electricity is produced there as the LED is lighting. Right? So LED lights up only when an electric current passes through it. So it's clear that electricity can be generated with the help of wind power. Right? So there are advantages as well as disadvantages in using wind power. What are these advantages and disadvantages, children? So the main advantage is it is free of charge. We don't have to pay any amount to obtain wind. Okay? And here these are the advantages. Does not cause any air pollution. So from wind power plants, harmful gases are not released. Therefore, it does not cause any air pollution. Right, children? Can be obtained free of charge. Okay? Less environmental damage. Okay? Less environmental damage, less environmental pollution. Right? So, what are the disadvantages? So, can we just put up these wind power plants just at any place, children? No. There are places in different areas with sufficient amounts of wind. In order to rotate a turbine, there should be a sufficient amount of wind. So in Sri Lanka, we have wind power plants in Hambantota, Puttalam areas. Right, children? So disadvantages. Wind sufficient to generate electricity can be found in limited areas. So this is a major disadvantage. Right? And the other thing, sound pollution takes place due to electricity generators powered by wind. A large noise is produced during the use of these different machines in wind power plants. So this causes sound pollution, but at the same time, it does not cause any air pollution. Right, children? So when we burn fuel, most of the time air gets polluted because of the harmful gases released. But here, that type of thing does not take place, but at the same time, in that particular area, there will be a certain noise. Therefore, because of that noise, sound pollution takes place. Right, children? Okay, we'll move on to the next. Right. So, our next renewable energy source is geothermal energy. So, even about geothermal energy, we learned in grade 6. Okay, children? Right. So, what is this geothermal energy? We'll go through this. Thermal energy generated. Thermal energy means the heat energy, right? Thermal or heat energy generated and stored in the earth is known as geothermal energy. Right, children, we'll underline this. Thermal energy. Right? Thermal energy generated and stored in the earth is known as geothermal energy. So in certain areas of the earth, temperature is high. So how does this happen, children? We'll go through this. Below the earth's crust, there is a hot and molten rock called magma. So in the 8th lesson, we learn about the structure of earth. Right, the outermost layer is known as the crust. The middle layer is known as mantle, and the innermost layer is known as the core. So when we consider the mantle, the lower mantle present as molten rocks. Because of the high temperature, rocks melt and it becomes liquid rocks. This is called magma. Right, temperature of magma is very high. Okay, so below the earth's crust, there is a hot and molten rock called magma. So here what happens, because of this high temperature in this layer, the water gets heated and turns into steam. Right now here, we can identify areas here, rocks heated by magma. These are the rocks heated by magma. These are known as hot rocks. Okay, these areas are known as hot rocks. Hot rocks. So then there are special devices to identify these type of areas with hot rocks. So then what we can do is, from one place we can identify those places with hot rocks, we can drill those places, and then we can send huge pipes through those places. From one side you can send them in, from the other side you can take them out. Right? From one side you send them in, and from the other side you take them out. And through one side you send cold water. Right? Through one side you send cold water, and so we'll consider this is the other part of this. So the other parts of these tubes like this. This is how it combines and inside the hot rock. Right, so from one side you send water in. So when this water passes through this tube inside the hot rock, because of the high temperature of this hot rock, this water absorbs this heat and water gets heated up and water boils. And from the other side, steam comes out. This steam is at high temperature and high pressure. Right, children? So this steam can be sent through a turbine, a steam turbine, right? A turbine can be rotated because the steam is at high pressure. Using that high pressure, we can rotate a turbine. So as the axis of the turbine is connected to a dynamo, when the dynamo rotates, what happens, children? Electricity is generated. So this high heat produced inside the inner layers of the earth can be used to generate electricity. Right, children? So this steam is pumped out to turn a turbine. This turbine operates a dynamo and generates electricity. Right? So this geothermal energy is naturally formed type of energy. So we can use it efficiently. Right, children? Okay. So here, the hot thermal springs, so hot water springs in different areas in Sri Lanka, an example of an instances where geothermal energy is used. Right, children, the water bodies also can get heated up because of the magma present underneath. So these type of water bodies are known as hot water springs. Now here in Sri Lanka, places where hot water springs in Sri Lanka. Okay. Kinya, Rankiriya, Galwaver, right, Mahaoya, right, Kulegama, right, children, those type of areas, there are hot springs present. Right, children? Okay. So here, more experiments should be carried out about generating electricity from these thermal springs. So even though we have hot water springs like these type of areas with geothermal energy, this entire process of generating electricity using this hot rock, so this geothermal energy, it needs a large amount of money. The cost wise it is very high, right? And at the same time, in order to identify those areas, in order to drill these areas, also we need special types of machines. right? Knowledge is necessary and high cost is also there. Right, children? So using geothermal energy seems very profitable because energy deep down the earth crust is used. Naturally formed energy is used, but there are disadvantages as well. But there are many drawbacks to using geothermal energy, right? What are these disadvantages? The places of the earth with a very high temperature are very deep in the earth's crust. Therefore, to use geothermal energy, the earth has to be drilled very deep, right? It needs a lot of energy and a high cost. Okay, children? And at the same time, look at this. Also, many hazardous gases and many chemicals can seep up from the underground, and finding a way to safely dispose of them is very difficult and dangerous. Sometimes those toxic substances can trap inside the inner layers of the earth, right? So in these instances, in order to generate electricity using geothermal energy, we need to drill the earth deep inside. So in that case, if these places contain these type of harmful chemical substances, they might release. Right, children? This is also a disadvantage. Okay, children? So we will write these advantages and disadvantages, children. We will write them separately. Right? Advantages. Advantages. Right? Naturally formed energy can be used efficiently. Right, children? Disadvantages. Disadvantages. Right? The cost is high. Right? What else? Harmful chemicals present in the inner layers of the earth might get released. Okay? Harmful chemicals can get released, right, in short form. So these are the disadvantages, and you need proper knowledge as well. Okay, children? So this is a renewable energy source. So magma is always there. Therefore, it will always, the area above this magma will always get heated up. Right? These type of areas will always be there. Okay, but at the same time, when we use them, there are some other disturbances as well. Okay, right. Okay, so now we are going to learn about the energy of flowing water. When we consider energy of flowing water, this is also considered as a renewable energy source. Right, children? Okay, so here, look at this. This is an old water wheel, right? From ancient times, people used the energy of flowing water to rotate water turbines. Now, ancient time, there was no electricity. Nowadays, we use this energy contained in flowing water to generate electricity. Even in Sri Lanka, we have many hydropower plants. Right? We have We have learned about the functioning of these hydropower plants many times. Right, children? But ancient people, they use the flow of water for a different purpose. Okay? So from ancient times, people use the energy of flowing water to rotate water turbines. Right? These wheels were used to grind grains. Right, children? They were used to grind grains. Now remember earlier when we were discussing about wind energy, we discussed about windmills using the wind power. So do you remember earlier during wind energy, we discussed how the wind power was used to grind grains. So in the same way, Asian people use the flowing water also grind grains. So these type of mills were known as water mills. Right, earlier we discussed about windmills. These type of mills were known as water mills. There you all can see here, water wheel is there. Right, water current, a water wheel is there. The water wheel rotates due to a current of water, flowing water. Right, the axis of this water wheel is connected. Now here, from inside, the axis of this water wheel is connected to the machine-like part where they used to grind grains. Okay, children, so this is why these type of places are known as water mills. Right, children, but nowadays we use this energy contained in flowing water in order to generate electricity. Right, children? We'll move on to the next. So we have this assignment to do. Use a cork, a bicycle spoke, yogurt spoons, papers, clips, and prepare a water wheel. Now these type of water wheels or small turbines, model turbines, we prepare during number of activities, right? So how to make a water wheel like this? Okay, so let's consider. So let's consider, you can take the cork like this, right? And then you can pass the spoke through this, like the axis, right? So we can take the spoke wire, bicycle spoke, cross this. So this is the axis. Okay, children? Then what you can do? Use a cork, bicycle spoke, yogurt spoons. You can fix yogurt spoons over here in order to make them as blades. You can use in a blade, you can cut small slits and you can insert these yogurt spoons to one side, okay? Like this. So using yogurt spoons, even in grade 6, we have done these type of activities, right? And this looks like a small turbine, right? So this is the water wheel. Then what do you have to do? Hold the wheel to a flow of water and make a thread to coil in the cork. Now here from this side, you can connect a thread like this and you can hang a small weight, right? You can hang a small weight and then what you can do, you can rotate this small turbine using a current of water, flowing water, and then you will realize when this rotates, what happens, children? This thread also turns round this cork and you can lift this weight. So these type of activities were also done by ancient people in order to lift weights, in order to grind grains. They used the help of flowing water. Right, children? So at school, you can do these type of activities with your friends. Right, children? So you will realize the use of water to do different activities. Right? We'll move on to the next. Right. So the activity now we are going to do is generating electricity with the water current. Earlier we did a similar activity to generate electricity with the help of wind. Right? Now we are going to do the same activity using a water current. Okay? So we are going to make a similar setup. So what do we need? We will write down 12 volt car cassette motor. Car cassette motor, and then we need an LED. We need a biscuit tin or small tin. And then this time we don't need mega bottles, but we need bottle lids. Bottle lids. We need bolt nails. A small pulley. And a thread. Right, children? 12-volt car cassette motor, an LED, a biscuit tin lid, bottle lids, bolt nails, a small pulley and a thread. Right, children? Okay, we'll move on to the next. So the method, look at the diagram. We will label this diagram, children, so we can get a better understanding. So these are the bottle lids. This is the biscuit tin. This is the thread, small motor, pulley cannot be seen in the picture very clearly, LED bulb. Motor, LED, thread, bottle lids, and biscuit tin. You can simply write the tin. Right, children? Okay. This setup is quite similar to the setup we made earlier. Okay? Right. Fix the bottle lids at a similar distance to the biscuit tin with the bolt nails. Fix the bottle lids towards the corner of the biscuit tin, towards the side only, because through the other side, from the other side, we have to fix the thread. Okay? So, fix the small pulley to the axis of the motor. Connect the car cassette motor of 12 volts with the twine thread in a manner as to be able to rotate it. Connect an LED to the motor and rotate the turbine with the help of a water current. So the similar kind of setup like before, earlier we rotated the small turbine-like part using a current of wind. This time we are going to rotate this part using a flowing current of water. Okay, children? We'll do this activity now. Right, children. Now we are going to see how electricity is generated using a water current. So a similar activity takes place in hydropower plants. Okay. So look what I have here. Look at this setup. Here I have a tin can. This is a tin can, and through two holes made on either side of this tin can, I have passed a spoke wire. Right? And spoke wire is connected to these two laboratory stands. And you all can see I have attached these bottle lids to this tin can, to this corner. Okay. From the other corner, you can see very clearly I have sent this thread around this tin can, and from the other side, this thread goes around the axis of this motor. Right? This is a car cassette motor. Okay. And you all know that when the axis of the motor rotates, now this is the axis, this thread goes around the axis. When the axis of the motor rotates, it generates electricity. So that is why I have to identify whether electricity is generated, I have connected an LED bulb to this motor. Okay. So in order to light up this LED bulb, we need to rotate this axis of the motor. So how am I going to rotate this axis? I am going to rotate this big structure, right? This turbine-like structure. This is a model turbine. This turbine-like structure, when this structure rotates, as this thread goes around this big turbine-like structure and also the axis, right? This axis also rotates. Okay, this energy is transmitted through this thread to the axis of the motor. Okay, so how am I going to rotate this turbine-like structure? I am going to rotate this using a flow of water. Okay, so observe very carefully what happens. Okay. Right, children. So you all observed what happened very well. When I poured this water onto this model turbine, what happened? Turbine started to rotate. When this turbine rotates, what happens? As this turbine is connected to that small motor using this thread, that motor also rotates. And thereby, when the motor rotates, the axis of the motor rotates, electricity is generated and the LED bulb lights up. Okay, so similar function takes place in hydropower plants. In hydropower plants, a large turbine is rotated using a flow of water. The axis of this turbine is connected to a dynamo. So when the turbine rotates, what happens, children? The dynamo axis also rotates and thereby electricity is generated. Right, children. There you observed what happened. So we made the setup like this. And using current of flowing water, what happened, children? We rotated this model turbine part. This looks like a small turbine. So then what happened when we rotated this one? It made the thread also go round this motor, axis of the motor. So then you could clearly observe that the LED bulb lights up. So after doing this activity, it's very clear that we can generate electricity using a flow of water. Right, children? Because without passing an electric current, LED will not light up. Okay? Right. We'll write this down. Observation. When we'll write model turbine. When the model turbine rotates, when the model turbine rotates, due to the flowing water. Due to the flowing water, the LED illuminates. Right? When the model turbine rotates due to the flowing water, the LED illuminates. So what is the conclusion? Electricity can be generated. Electricity can be generated using the energy contained in flowing water. Electricity can be generated using the energy contained in the flowing water. Right, children? This is the theory behind the hydropower plants. Right? Electricity can be generated using the energy contained in the flowing water. Right, children? Okay. So electricity can be generated by using the energy of the flowing water. So a location where electricity is generated using water is known as a hydropower station or hydropower plant. So this is a model of a hydropower plant. You all can see this picture. Now here this is where the turbine is present. So always the turbine axis is connected to the dynamo. So when the turbine rotates, now we have learned about dynamos. So inside the dynamo axis is connected to a large magnet from inside. Right? So when the magnet rotates, what happens? Next to the magnet, coil of wires present. So then when the magnet rotates, the coil of wire generates electricity. Right? So how to rotate the magnet? By connecting it to by fixing it to a turbine. Turbine is rotated in different methods. So in hydropower plants, this turbine is rotated by the water current. Okay, so here you all can see this is the water. This is the flowing water. Right? So you know that always the reservoir is made in a higher elevation. Why? What is the reason? Because we have learned about energy transformation, children. Right? What type of energy rotates a turbine? The flowing water contains kinetic energy. Any moving object contains a type of energy called kinetic energy. Kinetic energy rotates the turbine. To gain more kinetic energy, you have to store this water at a higher location. Because of the location of this water, the water stores a certain type of energy called potential energy. So during this activity, potential energy of water converts to kinetic energy of water. If more potential energy is present, the kinetic energy also will be high, right? So in order to get more potential energy, you have to store this water at a higher elevation, right? So this is the reservoir. From reservoir, water flows towards the hydropower plant. So power plant is always built below the reservoir, right children? So this is the dam, reservoir. Through a tunnel, water flows at high speed towards the turbine. Because of the high speed of this water, turbine also rotates at high speed. So when the turbine rotates at high speed, magnet inside the dynamo also rotates at high speed. Now we know that if the rotation of the magnet is higher, if the speed is higher, more electricity is generated. So thereby the efficiency of the hydropower plant can be increased. Okay children? Right. So a concrete dam is constructed by obstructing the flow of water to generate hydroelectricity. An artificial reservoir is created by that. Okay, here this is the concrete dam. Right children? Okay. The water thus collected in the reservoir is carried to the power station located at a lower level through tunnels and pipes. The water currents are used to rotate the turbines. Right children? So dynamos or electricity generators produce electricity by rotating turbines. Right children? Even in the third lesson under electricity we learned this process. Okay? Right. Hydropower is an environmentally friendly and profitable source of energy. Right? So when we consider the hydropower plants, they don't produce harmful gases. So basically because of this reason it is environmentally friendly. Okay children? So however, the initial cost of constructing a hydropower station is high. So here advantages, disadvantages both are there. We will write them separately. Right? Advantages. Advantages. Disadvantages. Right? So environmentally friendly. Advantage. We will write environmental pollution is minimized. Environmental pollution is minimized. Right? Profitable source of energy. However, the initial cost is high. Right? High initial cost. Right? Initial cost is high. Due to the artificial reservoirs, animals lose their habitats. Right? So when building these artificial reservoirs, what happens? Sometimes animals will lose their habitats. Right? We can write that also. Animals lose habitats or living environments. Right? These reservoirs are filled with sediment which cause an issue as well. Right? Sediments means substances deposited at the bottom. Right? Therefore, sometimes what will happen? Sometimes these reservoirs might overflow. When more and more substances get deposited at the bottom, at one point, overflowing can take place. Okay? Floods will occur too. Right? So, possible overflow of water. So in Sri Lanka, it is not possible to construct any more hydropower stations. So when you consider Sri Lanka, a country, there are many hydropower plants. Do you know the names of them, children? There are many hydropower plants like Victoria Power Plant, Randenigala Power Plant, Rantabe Power Plant, Upper Kotmale Power Plant, and there are many other power plants as well. Right, children? So all the possible places are taken up already. Okay? So in Sri Lanka, it's not possible to construct any more hydropower stations. All the possible locations have been used so far. Right? So if the expected amount of rain is not obtained, it is not possible to operate hydropower stations. This is why we experience power cut during drought seasons. When the environmental temperature is very high, during dry seasons, what happens? These reservoirs get dried up, and when the amount of water in reservoirs reduces, what happens, children? The energy produced by water reduces, and thereby the speed of rotation of these turbines reduces. Thereby the amount of electricity generated is also reduced. Okay, this is why we experience these type of drought seasons, we experience power cuts. Okay, children? Right, we'll move on to the next. Right. Now, as the next renewable energy source, we are going to learn about energy of biomass. Even about biomass, we learned in grade 6. What is biomass, children? The energy contained in plant and animal matter is known as biomass. Right? Biomass means plant or animal matter that can be used as fuels. Energy of biomass means the energy contained in any kind of plant or animal matter is known as biomass. This type of energy also can be used to generate energy. So most of the time by burning biomass, we can obtain heat energy. Right, children? So like firewood, by coconut shells, right, sawdust, we can burn these type of biomass and we can produce heat energy. This heat energy can be used for many purposes like cooking, heating water, etc. Right, children? There are some countries, by burning biomass, using the energy obtained by burning biomass, they can generate electricity as well in thermal power plants. Okay, children? Right. So, biomass energy is the energy which is contained inside the animal and plant materials. Right? The energy which is contained inside the animal and plant materials. Right, children? So, firewood is also considered biomass. So, firewood, when you consider Sri Lanka, the most commonly used biomass in Sri Lanka is firewood. Okay, right. Firewood is also considered biomass. The amount of heat generated depends on the type of firewood, type of the plant. Okay, children? Here, in India, dried cow dung is used as fuel to prepare food. Right? They use cow dung. They dry up this cow dung and then they use this dried cow dung. Like as some of us use firewood to cook food in hearths, in the same way they burn cow dung and using the heat, they cook food. Right? In India, dried cow dung is used as fuel to prepare food. Indian government encourages people to use cow dung to make biogas and use it as a fuel. What is biogas, children? Now we know what biomass is. What is biogas? Now these biodegradable materials, any kind of plant or animal materials can be collected in a sealed environment. Right? So these are known as biogas wells. Right? Biogas wells. So all these, let's say any kind of biodegradable materials, any kind of plant material, animal materials, right, like food waste, everything can be collected in a biogas tank. This is a sealed environment, right? Due to this sealed environment, a certain type of microorganisms can act inside the sealed type of environment in the presence of less amount of oxygen, right? So because of the functioning of these microorganisms and the less amount of oxygen, these biomass, or these plant and animal materials break down and a type of gas is released. This gas is known as biogas. Right, children? This biogas can be taken from an outlet and can be filled in cylinders and can be used just as LP gas that we use at home. Right, children? So to cook food, we can use this biogas. Right, children? So in India, dried cow dung is used as fuel to prepare food. Indian government encourages people to use cow dung to make biogas and use it as a fuel. So when you consider cow dung, it is animal excreta that also can be used to produce biogas. Right, children? So fuels produced using plant materials are considered renewable energy sources, because when it comes to biomass, biogas, these can be considered as fuel. They are made by plants. Right? Plants are something renewable. Therefore, the energy contained in biomass and biogas are also considered as renewable energy sources. Okay? Right. As long as we continue to plant new trees to replace those cut down, we will always be able to get those fuels. So in order to get fuel, some countries, they specifically grow plants in order to produce this biogas. Right? And also other biofuels. Right, children? Okay. So for extra knowledge here, in some countries, gasohol, which is a mixture of petrol is known as gasoline, right? Gasoline and alcohol both are fuels. So in some countries, they produce a certain other type of fuel called gasohol, right? So here it's a mixture of gasoline and alcohol, right? So gasoline, this gasoline gas part, right? So gasohol, GAS from this part, OHOL from alcohol part, right? Gasohol. Okay. So in some countries, gasohol, which is a mixture of petrol and alcohol, is used as a fuel for vehicles. Right? Some scientists are still experimenting on using different types of new fuels, right? Biofuels. Right, children? Okay. So electric rice cooker is used in many homes to cook rice. Okay. National Engineering Research and Development Center, or NERD, has introduced a cooker that needs pieces of coconut shells as well. Right, as fuel here. Okay, so coconut shells also considered as biomass. So instead of using electricity, a new type of rice cooker that uses coconut shells as fuel. Right, children? So it can be used instead of the electric rice cooker. Okay, children. So in that case, it is a low-cost product. So when you consider this biomass, what is the most important thing about using biomass? It is low cost, because it can be any kind of plant or animal matter can be used as fuel, right? Therefore, cost-wise, it is friendly to us. Right, children? We'll move on to the next. Right, children? We have this assignment to do. So we learn about number of renewable energy sources now. Okay. So this assignment says, list out the advantages and disadvantages of renewable energy sources. Now I am not going to do this. I will show you how to do this one, but I am not going to complete this. As we learn number of renewable energy sources now you can find out, you can list them out and you can write down what are the advantages and disadvantages of using these type of renewable energy sources. Okay, children? So how to do this one? You can do it in different ways. Here I will select to do it as a table. Right? So you all can compare very easily. Okay? So I'm going to take it as 3 columns. And here we can, in the first column, we can write down. I will do just one example. All the other things you have to do by yourselves. Okay, children? Right. So this is a kind of a summary of renewable energy sources. We have discussed about many types of renewable energy sources, right? We can here write energy source or renewable energy source. Advantages, disadvantages. Right? Energy source, advantages and disadvantages we can write. So I will write the first one we discussed about, solar power. Solar power. Right? What are the advantages that we discussed about? We can write free of charge. In short form, we can write free of charge. What else, children? No air pollution. No air pollution. What else? The electricity generated by solar panels can be stored, right? Electricity can be stored. But the efficiency of storing is less, but still we can store this electricity, okay? That is an advantage. What are the disadvantages? When the sky is cloudy, we cannot generate electricity efficiently. Right? Okay. Now disadvantages. What are the disadvantages, children? We will write when the sky is cloudy, electricity cannot be generated efficiently. Okay, you can write it as a disadvantage. Okay, right. So in this way you can go to the next one. So wind energy, likewise, advantages, disadvantages. So you can list out all the renewable energy sources we discussed in this lesson, and you can write down the advantages and disadvantages. This is like a short note. Okay, so when you do this activity, you will understand what you learned better. Right, children? Okay, so we have completed this chapter as well. So in this chapter, we learn about number of renewable energy sources. So in the next chapter, we are going to learn about non-renewable energy sources.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.